Hello students, in this session we will discuss about the different languages followed by Odmg data model. So here the first language that we are going to discuss is object definition language. So you might be remembering the usages of data definition language in SQL model. So what was that data definition language? Which was the language used for defining a table that is used in structured query language. So similarly in Odmg model we are using ODL language for creating the basic semantics or definition of the object representation in object data management group. So ODL supports the semantic constructs of Odmg model. Now when we consider ODL, which can be or which is an independent language of any other programming language that we are using for our application purpose. So ODL is different and programming language is different. By using some mechanism in between these two, we need to mix this ODL into our externally used programming language. Now ODL is used to create object specification. That means in DDL what we are doing is we are creating the structure of a table. Similarly here also we are trying to create the structure of an object. That means the object specification is to be made by using the object definition language. That is, we need to use the different classes and interfaces for creating object and that is defined or specified by using the object data or definition language. Now it is never used for the manipulation of database, that is part of Odmg model. So it is only used for defining. It is only used to define or making the structure of an object, just like a class or interface. Now we will see one very simple example of creation or creating a class by using ODL language. So we will see one class definition that consists of a class definition. So it is actually used for creating a university schema, university database. So the syntax will be like class name, which is similar to the class creation in any object oriented language like C++, class name. So here we are creating a class called as degree, then an opening parenthesis, opening curly bracket. Under that we are defining various attributes. So this is a simple representation of a class where we are defining or declaring an attribute called as college, then another attribute degree and year. So college, what are the features of this college attribute? We need to specify that attribute by using the keyword called as attribute. Then the data type of that attribute, that is string. A college is having an attribute of string type. Similarly, degree is also another attribute which is having a data type string. Then year is also an attribute which is having the data type string. So these three attributes, they are following the same data type string because they are represented in terms of string values. So this is a very simple class representation in ODL language. Class name, opening curly bracket, then attribute specifications. So here in this example we have given three different attributes by using attribute keyword, the data type and the name of the attribute, then put a semicolon at the end of each of the attribute. Then after the completion of all attribute specifications, we need to close the curly bracket, then put a semicolon that indicates the end of a class. So this is the basic syntax of using a class definition in ODL language. Now we will see a class with two more important terms, that is a key and an extent. In the previous video, we have already mentioned about the key specification and extent specification in general. So what was key? Key is used to specify a particular attribute as a key attribute that actually identifies that particular object. Similarly, extent was used for indicating an extent name. That means under which extent name that particular object belongs to. That means a group of objects. Like in the previous session, we have seen all employees. We have given an extent name called as all employees, under which all the employee objects are specified. So we need to specify an extent name for specifying the group of objects. The group name for all the objects belongs to that category. So a class definition with extent, key and more elaborate attributes we will discuss. So we can see this particular example. Class person, which is similar to the previous syntax. Class person, person is the name of class. Then within parenthesis, normal brackets, we can specify the extent as well as key. So within parenthesis, just after specification of class name, class name, within bracket, we need to use another keyword called as extent, then give a space, then provide the name of extent, that is extent name. I am giving here persons. So you can understand persons is an extent name under which a person object will be stored. So I am providing an extent name persons, then give a space, use the second keyword, that is key, which is used to specify which of the attribute can be considered as the key attribute of this particular class. So key is the keyword, then give a space, then provide the name of the key attribute, which is given here is SSN. So class name, within parenthesis, provide extent, give an extent name, then key, give the key attribute name, then opening curly bracket, then you can specify the first attribute. So first part will be attribute keyword, then we can have the data type, then we can have the attribute name. Now this is the attribute name, that is name, that you can see. But before that, under the data type, here you can see that it is again in a different format it is given. Now the specialty of this name attribute is it is again a structure type, or we can call it as a complex type. So complex type can be created by using a keyword called as struct. Struct p name, then again opening curly bracket, string first name, then comma string middle name, comma string last name. So it is not completely given here, so we can specify that structure here. So struct structure name, then provide the details of structure, then this is the name of the attribute. So what is the specialty of name? Name is again a structure type, which is again divided into first name, middle name and last name. So this structure we are specifying. So the data type of this name is a structure type, and provide the details of that structure here. I hope it is clear. So name is a complex type. Then we are specifying another attribute SSN, which is of built-in type string, which is considered as our key attribute here. Then another attribute birth date, whose data type is date, which is following date data type. So maybe this date is not actually a built-in type, so we need to specify date. We need to create a date class separately, so that we can have all the features of date that can be stored in that particular class. So the data type can be in a built-in type, or maybe a class type, or can be a further structure type. So any data type, so like in C++ we can use a class name as the data type of an element. An integer, a built-in type, can be considered as a data type. Similarly, here also we can consider some class name also as the type of the attribute. Then in this example we have one more, we can have any number of attributes here. Then you can see one function or operation is being specified here. The name of that operation is age, and we have given an empty parenthesis that indicates it is an operation or function, and the return type of this operation is short. Then put a semicolon here. So this is a further detailed example where a complete class, how we can define a complete class in ODL language. So once again, class name, then provide an extend name, a group name, then provide a key attribute, then opening curly bracket, specify all the attributes. Then for each attribute we can have the data type. Sometimes it can be a structure, we need to define a structure name, features of that, then provide the attribute name. Sometimes it can be a built-in type like string, or sometimes it can be a class, it can be another user-defined class that can be considered as the return type or the type of a particular attribute. And also we can specify some operation. Operations are usually specified followed by operation name followed by parenthesis. Then we can have a return type before specifying the name of the operation. Now we will see another example where we are using a class with relationships. In databases, one of the key feature is that we can specify the relationship between different tables. In normal traditional relational database system, we are aware about the relationship between different different tables. A student table is related to faculty table, a student table is related to library table, a patient table is related to doctor table or hospital table, etc. So we should have relationships between different data elements present in a particular database. So similarly, in object data or object definition language also, we can specify the relationships between different classes. So each classes will be having corresponding objects. So when we are specifying relationships between classes, implicitly it will be the specification of the relationships between objects belongs to those classes. Now we can see how we can specify the relationships. Now we can have two types of relationships that can be specified within a class. One is an extends, that is by using an inheritance relationship. That means one class is inherited from another class. One class is inherited from another class. That can be specified by using extends relationship method. And also we can have another relationship which is called as inverse relationship. We are usually specifying the reverse relationship. If A is related to B, how A is related to B, there will be some relationship. Similarly, we need to specify the inverse relationship also. That means how B is related to A. So the way in which we are specifying how A is related to B, we need to specify how B is related to A. That is in the inverse way. That is called as inverse relationship. So we will see one example that consists of the extends as well as inverse relationship in a particular class. So here we are going to define a class that is called as faculty, class faculty. Then we are using an extends keyword that is for relating two different classes. A class faculty extends person. So we are already having a class called as person, and this faculty is actually extended from the class person. Class faculty extends person, we can see this is the similar syntax as in Java language. So class faculty extends person. then we are specifying an extent. We don't actually require this extent usually, but most of the time we are specifying extent for providing persistence feature to all the objects that we are creating by giving an extent name and making that extent object or that name as the persistent object name. So whichever objects that are coming under that extent name will be also considered as a persistent object. So here we are specifying a name for the extent that is called as faculty. The name of extent which is given here is faculty. So class faculty extends person, and we are giving an extent name faculty. That means all the faculty objects will be under the extent name faculty. You can see this faculty, F is small letter, but this class name faculty, this F is capital letter. Then opening curly bracket, then the first attribute, which is a string type, attribute name is rank, which is clear. Then second attribute, float type, salary. Then attribute, string type, font. So three attributes are declared inside the class faculty. Then we can see the two relationships that is possible within this class faculty, or whichever objects that are created based on the faculty class. Now how we can specify the relationship? The relationship can be specified by using the keyword called as relationship. The relationship is the keyword that is used for specifying a relationship between two different classes. Now relationship, so what relationship we are going to specify? Relationship department, relationship with department. So this faculty is related to the class department. So faculty is one class and he is related to department, which is another class. And what is the name of relationship? Name of the relationship is works in. Faculty works in department. Faculty works in department. This is the order. So how we can specify that? Relationship name of department to which, the name of class to which the faculty is related, that is department. And what is the relationship? That is works in. Okay, so as I have mentioned before, we need to specify inverse relationship also, how it is oppositely related. So normally when we are specifying a relationship, we are specifying the inverse relationship also. So relationship department works in, so faculty works in department. Then by using inverse by using inverse keyword, how it is inversely related? That means department double colon. So this is the way how we are specifying inverse relationship. We have to use inverse keyword, then the department, that is a second class, double colon, has faculty. So faculty is related to department. Then the inverse relationship will be like department has faculty. Faculty works in department, department has faculty. So relationship department works in, and the inverse relationship is department double colon has faculty. So this is the way in which we are specifying the relationship and inverse relationship. Then you can see another relationship keyword. Then set of graduate students. So this is a class, a set of graduates. So graduate student, grad stud, that is another class, and thus that class will be having some objects. So set of graduate students, that means the set of students belongs to this class advisors. Okay, so how the relationship will be? Faculty advises a set of graduate students. Faculty advises a set of, normally a faculty group advisor, you will be knowing group advisor. A group advisor, a faculty advises not only a single student, right, a set of students. So he is advising a set of graduate students in this particular example. So that is again another relationship. In the previous relationship, a faculty related to department, one to one. Here we can see a faculty advises set of graduate students. That means one to many. This is a one to many relationship. Now the inverse of that is graduate student advisor, or has advisor, or some graduate student is associated with advisor, or that is the relationship. That is the inverse relationship. Graduate student is having an advisor from the faculty class. Faculty advises graduate students. Similarly, graduate students has advisor from faculty class. So this is the way in which we are specifying relationships. So you can see each relationship, direct relationship as well as the inverse relationship. So this is another relationship, direct relationship and inverse relationship. So normally when we are defining a class by using ODL language, we are specifying direct relationship as well as inverse relationship. So while specifying inverse relationship, we are using inverse keyword. Now you can see two operations that are also part of this class faculty. Void give rise. Give rise is the name of operation, and the parameter. So in the previous example we had no parameter. So here we are having a parameter called as raise, and the parameter that expects here is of float type, and this is an in parameter. That means from wherever this function give rise is being called, from there some value must be passed, like 10 is passed. So it is taken into, that is coming into this portion of give rise operation. From caller to callee, it will take the value from caller to callee. So that is the meaning of in and out parameter we are using in SQL also. Similarly in Odmg also we are using in type parameters. Similarly we can see another operation which is promote, which receives a new rank parameter of string type, and which is also taken from the caller operation. That value will be taken from caller into callee. That means from outside that value will be coming into the promote operation, which is considered as the parameter here. Accordingly, the body of this promote operation will be executed. Now, as I have mentioned in the previous class, in object database management or object data management group model, we are specifying classes, attributes and relationships as well as operations. And normally operations are simply giving declared, or we are giving only declaration, and the definition of these operations are normally given in an external object oriented programming language like C++, where the body is being given. So we should have some provision for connecting an ODL to an external object oriented programming language. So in association with an external object oriented programming language only, we can have the execution of an object definition language. I hope it is clear. If you are familiar with normal classes in C++ or Java, 80% it is similar, but we are adding some more features into the class concept that is already there in object oriented programming languages. Now we are considering inheritance itself by using another concept, by using single colon inheritance. So what is this inheritance? Why we are using colon? So regular class inheritance is done by using extends keyword, but colon is used for inheriting the properties of one interface into another interface. So this is also an inheritance, but inheritance is done by using colon. When we are specifying colon, this is for inheriting an interface into a class, not only between two interfaces. For including some features of an interface into a class, we are using colon. So in Java, you might be remembering between class, a class extends another class, but if a class is taking the features of an interface, we are using class implements. Class name implements interface name. Here in place of that implements, we are using colon. And for class to class inheritance, we are using the same keyword extends as in Java in ODL also. So for inheriting an interface into a class, we are using a colon syntax. So we will see one example: interface name. The name given is shape, and normally, as you know, interfaces normally consist of only declarations, right? It is only providing an abstract representation of something, or it is only providing some support to some other class. So here this interface shape consists of an attribute which is again a structure type that is having a point, a structure name is point, and which is having further elements, some elements that are included here with some data type, some type of values that are part of the structure type, which is used for the shape interface, and the name of the attribute can be given as reference point. So reference point is the name of the attribute, and the reference point attribute is further a structure type, and the structure name is given as point, and which is having some number of data elements that can be permitted to accept. And the interface shape also consists of another operation which is called as perimeter. That means to find out the perimeter of the given shape, which is actually the purpose of this shape interface. And the return type of that perimeter operation type is float. So we don't need to discuss in detail about the concept here. We just look into the syntax of interface, how we can create an interface which is almost similar to a class, but the meaning is different. So interface name, opening curly bracket, then write the attributes and operations there, then closing curly bracket and put a semicolon. So this is the specification of an interface. Now we will see how we can utilize this interface shape into a class. Now this is the class definition. Class name, so class triangle colon, that means this class is going to take the property of an interface. So triangle colon shape is the name of this particular interface, and I am giving an extend name triangles by using extend triangles. Okay, then opening curly bracket, then specify attribute, then name of the attribute, that is short side 1. Side 1 is the first attribute which is of short type. Then another attribute side 2 which is also short type. Similarly, we can have any number of attributes that can be created. So this shape is actually an abstract interface, some elements that must be followed in the class that utilize that particular interface. So we can have the number of attributes that is required as per our application. So you can again look into the interface declaration, interface name, attribute declaration, operation declaration. Then we are having class colon shape, that means it takes the properties of shape, and these are its own attributes. Along with these attributes, this reference point is also part of this particular triangle class, and this perimeter is also part of this particular triangle. These two properties are also added into the newly created class triangle. So this concept is almost similar to the interfaces used in Java. Now, so far we were discussing about the creation of class and interface, which is part of object definition language. So we are creating class creation is a definition. So we need to use object definition language like the syntaxes, class name, then extends, then extend keyword, key keyword, etc. Then relationship, attribute. All these are part of ODL language. Then while creating interface, we are using interface name, then different attributes and operations. Then for inheriting that interface, we are using a colon symbol that is different from extends. So extends for class to class, then colon for interface to class, how we can bring an interface into a particular class. So that is the ODL basic informations. Now in the next session we will discuss about the second category of language, that is called as object query language. Object query language, which is similar to the data manipulation language. The data manipulation language that is used in SQL model. So object query language. So OQL is the ODMG's query language, which is working very closely, or which is related to the programming languages like C++. So normally for retrieving some data from the objects that are already created by using ODL language, we need to apply some query. So queries can be entered by using OQL. Now this OQL statement will be executed in association with the languages that we are using corresponding to our object definition. So I was mentioning in the previous session, for defining operation itself we require the support of an object oriented language. Similarly, for querying a particular for writing some query and for accessing some objects or data, we need to enter the query, and this query will be executing in association with some programming language which is already part of that particular system. Now we can use embedded OQL statements that returns objects which are that objects are compatible to the type that is created in the C++ like language. Now what we are doing is we can use the OQL statements, like when we write a Java program, if you use some database connectivity in between, what we are doing is in between Java language we are including the SQL language, SQL statements in between. Similarly, in our high level C++ or Java language, we need to include these OQL statements in between. That means embedding the high level language statements and OQL to perform a particular database access in an object oriented database language. Now you can see OQL syntax is similar to SQL with additional features for objects. So almost the syntaxes are similar, almost we are following the same pattern that is used in structured query language, especially with data manipulation language in SQL for accessing various datas, and we are having some additional features that are used for adding or for accessing the objects that is present in object oriented databases. Now we will see some simple OQL queries. So the basic syntax of an OQL is select from where, which is similar to our SQL. SQL is also following SQL. We know select from where, select star from student where roll number equal to 10. Select star from employee where salary greater than 10,000. So the same syntax we are following in OQL also, but there are some differences. So we will see each sessions separately. So select from where. So what are the elements associated with that select from and where? Select d dot name. Select d dot name. So you can have a confusion here. What is this D? I need to select only name, right? But I am using a D there, D colon name. So I'll explain that what is that D here. I'll give that explanation. But just listen to the entire query syntax now. Select D dot name from D in departments. Assume this is departments. D departments. So as you can see, departments is the name given. Departments. Normally you can assume that this is the name of the extent. Departments. That means departments consist of more than one departments. D1, D2, D3, D4, etc. So this is departments extent. That means group of departments are there. So what is this D in departments? D in departments means we need to have iteration. First department, second department, third department, fourth department. So D in departments. So at a time one department and its name. So that is why we are using an iterator variable D here. We can call D as an iterator. Select D dot name. So name, which name? D dot name. D dot name means where is the current iterator, that particular name. So where is the current iterator? Maybe first time in the first position or 0th position. From D in department. So first department, take that name, D dot name. Okay, so that is the way how we are using the iterator variable in OQL query language. So select D dot name from D in departments where D dot college D, so for that particular department D dot college is equal to engineering. So from engineering, so whichever college which is having engineering, select the department name from the set of departments available. Okay, so this provision is not available in SQL. How we can select from a group? We cannot select from a group, right? We are having separate values from where we can select from a single table, but these departments actually consist of a number of department objects, and we are iterating through each objects, and for each from each object we are giving a search. So what we are searching for a department with department having the college which is of engineering type. So select D dot name from departments, D in departments where D dot college is equal to. So engineering department will be selected according to the condition. Okay, so the D is iterator variable. We will see some more description about this D later. So an entry point to the database is needed for each query. An entry point to the database is needed for each query. So which is the entry point? Entry point, that is D dot name. So what is to be selected? What is an extent? Normally here departments, which is actually the extent from where we are taking the okay, so an entry point which is D dot name, which belongs to this iterator variable, so that is taken from department. So entry point is generally considered as the extent name. It is served as the entry point. Okay, so an extent name with an iterator variable is considered as the entry point of any OQL query. So departments is the entry point. So from department we are retrieving some value according to some condition. So we should have an entry point for selecting the objects or values from an object oriented database. So entry points are normally the extent names like departments in this particular example. Now we will discuss about iterator variable. Iterator variables are defined whenever a collection is referenced in an OQL query. If we want to select some data from a set of objects, we need to use an iterator variable. So iterator D in the example serves as an iterator and ranges over each object in the collection. So for each object D will be considered. So first iteration, first object, second iteration, second object. Similarly, it can have a search among all the objects present under that particular extend name. Now we can have different options. So here I have given D in departments. Similarly, so D in departments is one option. In OQL we can also use departments space D, which is another option. Departments as D, this is also another option. So here we can change this, select D dot name from departments D, that is also correct. Select D dot name from departments as D, that is also possible. So these are various syntactical options that are used for specifying an iterator used in OQL. Now data type of query results. So what will be the type of results that we are producing from a particular OQL query? The data type of a query result can be any type defined by normal Odmg model. We always don't require to follow the normal select from where format for accessing the database contents. We can use some other query format also. So this is the basic format of accessing elements from object databases, but we are having some other options also. Now a persistent name on its own can serve as a query. A persistent name, so in the previous example, a persistent name like departments is the persistent name, a group name that is given for the entire department objects, group of department objects. So a persistent name itself can be served as a query. That means departments semicolon, which will actually retrieve all the departments. So simply providing department semicolon itself will serve as a query, whose result is a reference to the persistent object, a reference to the entire object that holds all the objects for that particular department's extend name. And its type will be, the default type will be set of departments, a group of departments. Now similarly, we can specify an OQL query by using path expressions also. We can use path expression, which is used to specify a path to the attributes and objects in an entry point. So in departments extend, if I want to refer to a particular attribute, we can use a path expression. We need to provide the path, how to reach that particular attribute. Normally that can be possible only through the object with the support of an extend. Okay, so a path expression starts at a persistent object like departments or its iterator variable. We can use the iterator variable also for setting the path expression. So the name will be followed by 0 or more dot connected relationship or attribute names. For example, a path expression is given here, departments dot chair. So from departments extend, from that set of departments, select the chair. Okay, so similarly in the previous example, departments dot HOD, departments dot faculty. So we are reaching into a particular attribute belongs to the extend name, where we are having a set of objects belongs to this extend type departments, maybe a department 1 chair, department 2 chair. So we can have a path expression is also, we can write the OQL in a path expression format also. Now views as named objects. Now view concept in databases. So we can use this view concept by using the named objects concept in OQL language. There we are using the define keyword to specify an identifier for a named query. We can use a define keyword to specify an identifier. If a query, an entire query is given, For that query I can provide a name by using define. I am giving a particular name for that particular entire query, and later I can use that name for referring to this particular query. The name should be unique. So whenever we give a name for a particular query, the name should be unique. So you cannot give the same name for more than one queries. So that is to be taken care. So once a query definition is created, it will persist until deleted or redefined. A query is being defined and I have given a name. That may, by using define, if I am giving a name, it will be persistent until it is deleted or redefined. It can also include some parameters also. So you can see that an example of OQL view. Here this view is to include students in a department who have a minor. You can see a student or including all the students in the department with a minor course. So define keyword has minor of department name. Okay, so what is our aim? I am creating a query and I am giving a name, and later by using that name I can access the similar operations that is followed by, or whichever situation we need this particular query, we can use that single view name. Okay, so define. So I will be defining, giving a name like has minor of department name. Has minor of department name. So department name is of course it is an attribute present in department class. So has minor of department name. So I am giving a view name. It is just like we are giving a view name in our normal database in SQL view. So define view name. View name is has minor of department name, because has minor is the name which is having a parameter department name. We don't always require this parameter, but in this example has minor is the name of view with a parameter department name, which is an attribute of department class. Then as another keyword. So define and as, they are keywords. As, then provide the query. Select yes from yes in students where s dot minor in dot d name is equal to department name. Select yes. Select s, simply s means select all the elements. S dot d name means only department name need to be selected, but select s means all the elements to be, it is just like select star. From, so s is the iterator variable here. We can use any variable. Select s from s in students. So from students extent, we need to select all the details of student where s dot minor in. So minor in is the relationship s dot minor in dot department name. Minor in dot department name is equal to so there is a relationship in student where minor in department name. A student minor in department. A relationship is already there, assume. That is the situation. S dot minor in dot department name is equal to department name. So whichever parameter we are receiving here along with this view name, if that department name is having a minor, and whichever students are selecting that minor, these students detail will be selected. Select all the students from students where the students with minor in the department that is passed through this particular parameter. That is the meaning of this entire query. And what is happening here? I am giving a name has minor with a parameter as the name of the view. Now later, once after defining this view, later I can simply type has minor of CSE semicolon, which is a query will retrieve all the students who have taken CSE as the minor. We don't need to specify these entire queries again and again. So some complex queries can be written only once. Give a view name. Later by using that view name, we can execute the same query again. Has minor of CSE. So CSE will come here. CSE, select all the students from students where minor in CSE. So whichever students are having minor CSE will be selected by using this view name. So this is a simple way of using the object query language. Now next one is single elements from collections. How we can select a single element from collections where we are having a group of elements present. Now an OQL query normally returns a collection. Now an element operator in OQL is used to return a single element from a singleton collection that contains one element. So if you want to select a particular element from a group with a condition, we can use an element operator or element query. So the query can be written as element of, write the query, then element of query, that is the syntax. So whatever that query returns, from that one element will be selected. Select D from D in departments. Now it is directly written. In the previous example it was written in the next line, but here select D from D in departments, where D dot D name is equal to software engineering. So select the department with software engineering, and that element can be directly selected. It returns that particular element. It can be utilized as part of some other operation also by using element keyword or element query. Okay, so it is a singleton collection. This means several departments are there, but from those departments only software engineering departments, that will be only one particular software engineering will be selected, and that element will be returned. If D is empty or has more than one elements, an exception is raised. So when we use element, suppose if the statement is returning null or 0, or if it is returning more than one value, it will create an exception. So singleton collection should always, so this query should only return one value. For that one value, if you want to opt that single value, we can use element that will return the single value that is selected from this particular select statement. Then collection operators. It supports a number of aggregate operations. You might be remembering aggregate functions in SQL like AVG, SUM, count, etc. Similarly, in object data model also we are using in OQL part, we are also using some of the aggregate operations like min, max, count, sum, AVG. All these are similar to our SQL. Count returns an integer, others return the same type as the collection type. Count will always return integer. Min of depends on the type. Max also depends on type. Sum also depends on type. Average also depend on the type. Now an example with aggregate operator. To compute the average CGPA or GPA of all seniors majoring in business. So the meaning is to compute the average CGPA of all seniors, maybe one class, anyway one class whose major is business. For example, for all the engineering whose major is computer science, for example. So this is a foreign concept, so that is why they are using this major and all. Here we are not considering major, minor. Nowadays we are also having minor courses. So our major will be CSE. Minor, they can select some electronics or mechanical as their minor course. So here we are considering about a final year students who is majoring in business. So how we can select this? So AVG of, then we have to specify the select statement that select all the students who is majoring in business and their corresponding CGPA. Select s.gpa from s in students. This portion is clear, where s.class is equal to senior. So those students class is equal to senior, and s.majors in d name equal to business. Very clear, very simple, right? So some CGPAs will be, a group of CGPA will be created as part of this select, and the average of those CGPAs will be returned by this AVG operation. I hope it is clear. Now another concept is membership and quantification. OQL provides membership and quantification. I hope you are familiar with these two terms. Membership, so something is a member of some other group. Quantification, like there exists or for all these are quantification. So you can see membership and quantification, how we can specify that in OQL. E in C is true, so here normally membership and quantification we are actually expecting for a true or false answer. E in C is true if E is in the collection C. So if you are entering E in C, it is just like a question whether E is in C, true or false. It will return true if it is there, if this element is in C. If it is not in C, it will return false. Then for all E in C, B. For all E in C, so C is the collection. For all E, for all the elements in C, it is true if all E elements of collection C satisfies this condition. So B is a condition. It is returning true if all the elements in the collection that satisfies B. If anyone satisfies or if anyone is not satisfying, it will return false. If all the elements in the collection satisfies this condition, so I am having a collection with 3 elements, and if each of these 3 elements are satisfying the condition B, it will return true. If any one fails, it will return false. That's all. Then exists, there exists, like that, exists E in C with condition B. So it is true if at least one among these elements in this collection C is true, that satisfies B. If at least one element that satisfies the condition B that belongs to collection group C, it will return true, otherwise it will return false. Okay, so at least one it satisfies, it will return true. If all are failure, it will return false. Now you can see one example of membership. To retrieve the names of all students who completed CS 101. To retrieve the names of all students who completed CS 101. Select s dot name dot f name. So name is further struct complex type. So select s dot name dot f name. So s dot name dot f name, from name we need to select f name, comma s dot name dot last name. This is also possible. From s in students, where CS101 in, then it is just like a nested query. Select c dot name from C in s dot completed sessions. Select c dot name from C. That is, we are using another iterator in the next part, that is within the first select we are using another select where we are using another collection where we are only passing through completed sessions. CS101, then completed session. So it will select all the students who have completed the CS101 course. Okay, so CS101, this element in a group, CS101 in a group, E in C, that is the syntax of membership. Now you can see ordered collection, how we can order. It will be some sorting order, right? Ascending or descending order. So collections that are lists or arrays allow retrieving their first element, last element and ith element. This is also possible. OQL provides additional operators for extracting a sub collection and concatenating 2 lists. That is also possible. It also provides operators for ordering the result, that is sorting the results. So you can have retrieving of the first element, retrieving of last element, ith element, extracting a sub collection, a subgroup of a particular collection, or we can concatenate 2 set of elements. All these are possible with Odmg OQL query language. Now you can see an ordered operation to retrieve the last name of the faculty member who earns the highest salary. To retrieve the last name of a faculty who earns the highest salary. So we need to find out, we need to order the faculty in based on the salary. So first we need to find out the first, means among the set of salary who is first. After ordering in descending order, first element, retrieve the first element. That is the concept. So first, within that select struct, we need to select faculty colon f dot name dot last name. So we need to select last name comma salary, that is f dot salary, from f in faculty, order by salary, descending. That's all. It's a very simple concept. Select. So you can simplify this statement by simply select name. If the name is not complex, select name from f in faculty, order by salary, DESC. So it will select the first element. So it will be a list. It will be a list that is ordered in descending order. From there, just retrieve the first element. So we can directly take this value for any other operation. Then next operation is grouping operator. Grouping operator. Group by. You might be remembering group by in SQL. It supports grouping operator, that is used by or the term that is used for grouping is group by. So we will see one example to retrieve average CGPA of majors in each department having greater than 100 majors. We need to retrieve all the majors CGPA average with each department which is having more than 100 students present in majors. Select department name comma average GPA. Average GPA is further complex. Average GPA, it will be identified average GPA, the name, I am giving a name here colon, then average will be found out, AVG of select P dot GPA from P in partition, from S in students, group by department name. So just remember these terms, group by department name, S dot majors in department name, having count of partition greater than 0. Okay, so just remember this, select something, then you should have an average here. Normally group by should have some aggregate function like average or sum. Normally they are associated. If you know SQL, it will be clear. From S in students, group by department name, colon, D name, or S dot majors in D name, having count of partition greater than 100. So some condition is given. According to this condition, this is a particular condition, that is why we are using this concept. Just understand select from group by having. So we can have group by alone, and we can have a condition along with group by using having. Having is used for providing a condition that is part of group by. Having is not mandatory. It is also possible to use having along with group by. So that is all about OQL. We have seen the basic syntax of OQL by using select from where, the basic syntax, and we have seen the path expression. We can give a path, entire path for accessing a particular element. We can also have single element statements. We can have single statement for accessing, or we can have some view names for, we can provide some name for a particular query so that we can reuse that query by using the view name. And we have seen various options like grouping, aggregation, assistance, membership, quantification, etc. All these properties of SQL can also be applied in the object query language also. So here we were specifically looking into the OQL syntaxes. That is part of the basic ODMG model. So generally in this chapter we were discussing about ODMG model, ODMG basic features, then ODMG object definition language, how to create classes and interfaces, And in the second session we were discussing about OQL, which is used to querying or manipulating or accessing different elements or objects that is part of an ODMG model which uses object oriented databases. So that's it for now. Thank you.